हेलो गाइज, वेलकम बैक। एक्चुअली मैं प्रोग्राम सॉल्व कर रहा था, मुझे लगा कि मैं लाइव हूँ, बट एक्चुअली मैं लाइव नहीं था। देन मैंने फिर सॉल्व करना स्टॉप कर दिया। सो या लेट्स स्टार्ट फ्रॉम प्रॉब्लम नंबर 8. I solved, I think, offline from 3 to 7. So yeah, let's start from 8. Let me explain you the previous problem which I solved. It's like problem number 3, as you are already familiar if you are following this live stream. So this is the relation between log of r and 1 upon t square, and we have to find out the resistance as a function of temperature. So this is what we got, but option is not matching, but we can understood ln r naught as a constant, we can ignore that, and approximately we can match with the option number C. So yeah, that's correct. Now we solved 4. It's easy one. It's like most easiest one if you know already what to do, but if you don't know, I just solved from the ground up. So it took a little longer, but we got it. And then 5 number is the simplest one. I think a rod is connected to a circuit, but it's not soldered or something, it's just placed over it, and there is a region of uniform magnetic field, and as soon as the circuit closed, current will flow, and rod will experience a magnetic force that will uplift the rod, but it is placed in the gravity. That means mg will also continue to work upon. That means magnetic force will have to overcome mg to lift up the or to disconnect the circuit. So we have to find out the maximum potential of the battery so that it will continue attached with the circuit. So we just applied the limit. It's like if magnetic must be smaller or equals to mg, then we solved out. And then question number 6 was pretty easy one, like it's like from gravitation. So a body is dropped, or you can say released from the r height from the surface of the earth, and we have to find out the velocity as soon as it reaches the ground. So we just applied the conservation of energy. And 7 number, again each one, we just drawn a line of symmetry, and the resistor, as you can see, both side of the line of symmetry are identical. That means ki, in the middle resistor current will be 0. That means ki we can remove from the circuit, and after that we got a parallel circuit, and we solve it out. And now we are at 8, and a charge is flowing in a conductor as a function of time, and we have to find the minimum value of the current. So let's start from here. So we will just I think you got it. Let's accept the completed Copal solution and see if it's right or not. So yeah, we know that the current is rate of change of charge, yeah, right. Rate of flow of charge, that will be better. So yeah, rate of flow of charge, it's all right. And then I differentiated, sorry, Copal I differentiated it for minimum value di upon dt is correct. Then we got time is equals to something interesting. Yes, I to be minimum, again we have to differentiate. That means, yeah, that's right, that means I must have been alpha minus b square by 3. Yeah, it's all right, it's correct. So as you can see, Copal just doing fine, not fine, excellent job, I think. So let's move on to 9 number. I think you have got the solution already. We have a function of charge and we have to find out the minimum current. That means we just differentiate the q, we got the equation for the current, and then we have to minimize the current. That means again we have to find out the derivative of current and turn to 0. That means we find out the derivative of I, and we can equalize to 0 for the minimum value, and we got the minimum value. Again it's not accurate in the most pristine way, but it's okay because if you want to find out exactly the mean value or max value, we also have to find out the double derivative so that we can identify identify as proper minimum or maximum. We don't know because at minimum the function derivative of the function 0 tends to 0, and also at the maximum derivative of the function turns to 0. So here we have to just it's like we didn't verify is it minimum or maximum, but we can take it. Or if you really want to be sure, then you can find out the double derivative. If double derivative is positive, that means we are really sure about the being minimum value. So let's move on to the next problem. I think if I zoom in the window, I got a little weird, so I think that's okay. So let's move on to next problem. If you want Copilot to suggest, you have to just wait for a few seconds and it will complete accordingly. Let's accept this solution as well and run it without modifying. So again, a bar of resistance 160 ohm is melted and drawn into wire 1/4 of its length. Yes, it's perfectly fine. That means the volume of the wire will remain constant, but the area will get increased. Also the length will shrink, which is 1/4. The new resistance of the wire will be, so let's calculate. The initial length of the wire, absolutely fine, roll upon it. As the volume of the wire is constant, that means I think it's not perfectly okay here, because I know it's right, but I'm not satisfied with that. Yeah, it's right, but not in the perfect way. Because this is not the volume. I don't know. I should let it be like this, or yeah, it's okay, but not the perfect way to solve this. How can you say volume? Yeah, volume is constant, but I don't know. I'm not sure. Let's modify. Don't depend on it wholly and solely. So let's change it. As the volume of the wire remains constant, that means resistance will get like rho L upon wow. Because I did in the past like this, that's why Copilot is getting better and better. Wow. And it will change to volume, I know, because I did it in the past. So yeah, perfectly fine. Now body melted on 1/4 of the length. Wow. LS, yes. Let's run it. So as you can see, it's perfectly fine. Wow, it's great. So Copilot doing great job here. So as you can see, we find out the resistor as a function of V, and then we put it L dash L by 4, then R dash we can say L dash square upon V, and then after we put it everything as following, and then we got 10 ohm, it's correct. So let's move on to problem number 10. So again you can see copilot is suggesting pretty good. Let's wait for a few seconds and then let the copilot do the job. Wow, I think it's not right, but I don't know, because it's just messing thing up horribly at the end. It started well, but I think at the end it just messed. So let's not accept everything. Let me first read the problem. Two planets A and B have the radius r and 1.5 or densities are given. Ratio of acceleration to gravity at the surface B to A. That means we can find acceleration to gravity for both the planets separately, and then we can move on. So like let's accept a few lines. By the way, you can accept with the command right arrow key, word by word. This way you do not have to press tab and accept whole thing. So now you can press tab. Let's finish it first, and then let's run it, then we can modify further. Yeah, so let the mass of the planet ABMA and the mass of the planet BMB, and also let's leave it like that. Yes, it's correct. Then mass of the planet V, perfectly fine, seems for me. And then into text, yeah, the acceleration to gravity inverse to square the distance from the center. No. Yeah, into text. Now we can apply the equation for gravity. Yes, for planet A, GA, wow, RA should be there. RA, let's run it first. So GA, yeah, is perfectly fine. Let's continue with this solution, and I think 4/3 g pi r square will get cancelled. Yeah, it's perfectly fine. Now similarly, yes, for GB, yes, perfectly fine. So wow, no, let's run it first. One by 2 must be 3/4. What it's oh, something is missing right here in the yeah, something is missing right here in the that is why you should always run and check the solution beforehand. So let's run it first, then we can modify later. So as you can see, 1.5 r square is totally get cancelled out by the cube. One single term will still remain, but it it is missing the point of 1.5. So let's put 1.5 instead, and then see what happens, and then we can proceed from there. 4 by 3, no, it's not right, because it's just totally missing the 1.5 part. That means we will have 3 by 2. Let's say here defrag. Yes, 1 by 5, and then it will hopefully get, yes, see, now we can proceed accordingly. Yes, yeah, 1 by 4 still is missing the point. Let me see one more thing. Let's run it first, then see what it is missing. So yeah, 2 will cancel out, then 1 by 3, yeah, everything is fine. Then we can 1 by 4, that means, is this solution right? Sorry, is the solution wrong? Oh, let me see something. 3 by 2, 1 second. Oh, sorry, I missed something. Not 1 by 3. Oh man, my mistake. Yes, my mistake. Actually we have to put 1.5 means 3 by 2, not 1 by 2. That is why it messing thing up. Yes, 3 by 2. Now we can proceed. 3 will get cancelled out. How it is calculating, man. 4 will, everything will be gone. Everything will be gone. Yes, so there is no such thing as fraction. Yes, just remove this portion and then 3 by 4. Yeah. So as you can see, we got the solution 3 by 4. So it's over for problem number 10. Now move on to problem number 11, I guess. So as you can see, sometimes Copilot miss a pretty trivial thing, but then after it just start getting after modifying that thing. So let's move on to 11. So let's wait few seconds, then it may hopefully finish the completion thing. I think firstly I'm gonna, wow, this time it finishes the geometry as well as the solution. Let me see it first, how it it's just messing everything, but unfortunately it got the answer right. I don't know why, but it did. So let me fix this diagram. Just copying my style from the previous circuit. Yes, as you can see, in this problem I just drawn a line of symmetry, then we calculated the parallel equation, and it is trying to do the same. And because after converting all this convergence method, it will eventually convert to parallel circuit, and that is why it got the right answer. But the concept behind is like lame. So how can I fix this? How can I fix this up? Let me solve this problem little differently. I hope we will able to finish that. Yes, so we have to move the C point down, D point up. So let's try first. Yes, so where is D? Yes, D. So we have to move D little upward. Yes, and C little down, that means we are folding basically. So let's run it. Oh yes, wow, oh, beginning. And basically do a little higher, yeah, and then do. Now let's see what happens. Wow, and I think A to D. So there, we can just join this person directly, A to D. Let's remove this part. And also C to B. And let's see what happens. And remove this copilot thing, and then I think this is not the right way. I'm not feeling well. Let me do something different. Let the point remain same. Let's firstly fix the coordinate. So A and D should be at the same point. That means A and D, right? And B, so let's remove the D point. And then become B and C. So B will be exactly the same as the C. Let's remove the point C, and then we can draw A to C. So C is not there. So this will be bad, man. I don't know what. Let's say A to C. That means A to, let's say, plus, then 1, then 0.5. I think that will be better. Then 2. Yeah. C, but this time we have to use B. And let's comment out this thing and run this first. So I think I messed thing up, but we have to fix the B part. So A comma 0 is I think again we did not do, yes, 2 A comma 0, and then do B. So this is how we can change. B is like frost bited. So let's fix this B thing to A plus 2. That means it will shift 2 point towards right, and this is yes. So yeah, this is right. And this is how we can modify further. So next is C to D. Let's fix this, and this is 20.